You flip a switch and the lights just come on. It feels so simple, right? But behind that wall, there's this invisible web of rules, a whole electrical code that's designed to keep us safe from all that power. Today, we're going to crack open that codebook and demystify two really important rules. One's about a special kind of transformer, and the other is about how to safely tap into a circuit. Let's get right into it. So, here's the game plan. We'll start with the main grounding rule for auto transformers, and then look at the two big exceptions. After that, we'll jump over to tapping conductors and why an all-pole switch is so important. And finally, we'll tie it all together and see why these rules really matter. All right, let's kick things off with the auto transformer rule. This one is a real cornerstone for safety. We're going to start with what you're not supposed to do, which then makes it really clear why the exceptions exist. But hang on, before we dive into the rule, we all need to be on the same page. So, what in the world is an auto transformer anyway? Well, think of it as a super efficient transformer. Instead of having two separate coils of wire, it uses just one winding that cleverly does both jobs. It's both the primary and the secondary. This makes it perfect for making small voltage adjustments, like, say, bumping 208 volts up to a clean 240.
And here is the rule itself, straight from the code. What it's basically saying is this: you cannot create a new circuit from one of these unless you tie its grounded wire back to the main system's ground. You got to think of this connection as a safety anchor. Without it, the voltage on your new circuit can just float, creating a really dangerous shock hazard.
Okay, so now that we have the main rule down, let's talk about where it gets interesting. Like any good rule, this one has a couple of very specific exceptions. Because the code knows that in certain controlled situations, that safety anchor isn't always needed. Let's see when you can bend the rules. So, there are two key exceptions, and they're built for completely different worlds. The first one is for common, everyday voltage swaps. The second one, that's for heavy-duty industrial use, where you have experts watching over everything. All right, exception number one, this is the one you're most likely to see out in the wild. It covers that very common job of boosting a 208-volt system to 240 volts, or the other way around. Because it's such a standard, predictable change, the code says, okay, you can do this without that extra grounding connection. Now, exception number two. This one takes us into big-time industrial settings. We're talking much higher voltages here. It applies when you're changing between 480 and 600 volt systems. But, and this is a big but, it only applies in these industrial facilities. And there's another really critical catch. And here it is. This is the non-negotiable part. This exception is only on the table if there is constant, professional supervision making absolutely sure that only qualified persons, trained pros, are the ones working on this equipment. This isn't for your average commercial building, and it's definitely not for a home workshop. The stakes are just way too high. Okay, let's switch gears. We've been talking about creating whole new circuits. Now let's talk about tapping into circuits that already exist. Rule 210.10 is all about how we can safely tap power from ungrounded conductors to run new equipment. So this rule gives us the green light to tap into the hot wires in a circuit. And that's incredibly useful, right? For adding new stuff. But you probably guessed it, there's a huge safety catch involved to make sure that when you shut something off, it is truly off. And that catch is what's known as the all-pole switch requirement. The name sounds a little technical, but the idea is simple. It's all about making sure that when a switch is in the off position, the circuit is completely, totally, and safely dead. So here's how it works, broken down. When you tap into those hot, ungrounded wires, the switch you install has to have a separate contact, or pole, for every single one of those wires. And here's the most important part. All of those poles have to open and close at the exact same time. The code is super explicit about this. And why? Well, it's to prevent that nightmare scenario where you flip a switch, you think a machine is off, but one of those hot wires is actually still live. This rule makes sure that off means off. No exceptions, no leftover energy. And don't think for a second this is just for some obscure industrial machine. Look at this list. This rule applies to a ton of equipment we see all the time. We're talking appliances, heaters, motors, you name it. It's a fundamental safety measure that's all over the place. So we've walked through two pretty different rules, right? One for auto transformers, one for tapping circuits. They seem like separate issues. But if you take a step back, you'll see they're both built on the very same bedrock principles of electrical safety. Let's just boil it all down.
Rule 210.9 for autotransformers is all about creating that stable ground connection, that safety anchor to stop dangerous floating voltages. And Rule 210.10 for tapping is all about ensuring a complete, total shutdown of power. See? Two different rules, but they share one goal, protecting us from unexpected electricity.
So the electrical code, it's really not just a dry set of rules. It's a blueprint for safety that's been written over decades. The next time you flip on a light, you'll know a little bit more about that hidden logic that's working to keep you safe. It really makes you wonder, what other parts of our invisible world will you see differently now?